Welcome to this new video series where I review open source apps that are made with Flutter. I decided to start this new series because there are far many tutorials about toy projects rather than real apps. So my goal is to show you how real production apps are built and whether they follow good software development practices. And if they don't, what could be done differently so that you don't make the same mistakes in your own apps. And while it's easy enough to find open source Flutter apps on GitHub, and in fact there's even an entire directory about them, it's not so easy to find interesting ones that are worth reviewing. So my criteria in choosing apps for review is that they should be published on the app stores, they should have a decent number of downloads, and they should be complex enough so that we can learn something useful from them. And today we are looking at Cashew, which is a finance budgeting app with over 100,000 downloads and fantastic reviews. We'll dissect its architecture, code structure, and see what lessons we can learn. And trust me, there will be some surprises. Alright, so let's take a closer look at this repo. And as we can see, the app is published on the App Store, Google Play, and also available as a web app. And it looks like it was featured multiple times on YouTube by this channel, which has over 500,000 subscribers. So it is fair to say that this app has received a lot of attention. And in fact, if we open it on the Play Store, we can see that it has over 100,000 downloads with 4.9 stars from 15.7k reviews. Likewise, it has similar ratings on the App Store. And if we read the reviews, we can see that users are literally raving about this app. So yeah, this is a pretty successful app, and it is presented very well, and it's also been around for quite some time. And what is even more impressive is that it was created by a single developer. And this is very commendable and actually quite impressive. With that said, let's take a closer look and see if we can learn a bit more about the history of this project. And as we can see from this Insights page, the project was started in September 2021 and the last commit was in October 2024. And this means it has been actively developed for over 3 years, which is much longer than your average side project. However, we can also see that the latest release was made in July 2024. So it's been a while since the last update. And when I discovered this, I expected to have some challenges when running the app. And if you've ever been in a situation where you inherited an old codebase, you'll know what I'm talking about. So make sure to stick around until the end. Alright, so this completes the high-level overview of the app. And this means it's time to do a proper code review. And as part of this, I wanted to inspect the source code, but also be able to run the app. Because if I can't even run the app in the first place, I can't really dive in and understand how it behaves at runtime. So here is what I did. As a first step, I decided to fork the original repo, and then I opened it in my IDE and made some changes in order to get it running. So let me show you some of the steps that I took and some of the decisions I made. So here I have the Cashew app open on my cursor IDE, and if I open the terminal, I can run flutter pub get to get the packages. And as we can see, as soon as I get this, I get some dependency issues. So what can we do at this stage? Well, before making any changes, I think it's a good idea to open the pubspec.yaml file and see what's going on. And if we scroll down a bit, we can see that, wow, we have like dozens and dozens of dependencies. So this is gonna be a tricky one, I think. And with this many dependencies, it would be a huge headache to update them all. So instead of upgrading them all, I think at this stage, it might be a better idea to downgrade the Flutter version until we find one that works. And as it turns out, Flutter 3.22 was the one that works. So what I've just done is to use Puro to switch to Flutter version 3.22. And now I can use it to get the packages using that version. And as we can see, this time the command has succeeded. So the takeaway here is that if you inherit an old codebase and you need to get up and running quickly, you might be better off downgrading the Flutter version rather than trying to upgrade all the dependencies, especially if there are dozens of them, like in this case. And by the way, in this kind of scenario, tools like Puro are a godsend because they allow you to easily switch between different versions of Flutter when working on different projects. Okay, so it looks like we've managed to resolve the dependencies, but can we actually run the app? Well, as it turns out, running the app on Android was a bit of a pain because I had to upgrade the Gradle scripts manually, and it took me a little while to get it working. And funny enough, in the process of doing this, I discovered something interesting. In fact, as you can see here, there are a bunch of Firebase config files that are included in the repo. And this is not something that I would recommend for open source projects, and I truly hope that the app is secured properly on the backend. So this is just something to be aware of. On the other hand, when it comes to iOS, we are in luck, because all we have to do is to remove the old podfile.log file, and then we can go ahead and run pod install like this. And as you can see, this command completed successfully. And this means that after doing this, we can run the app and test it on the iOS simulator. So let me pause the video quickly and resume when the app is up and running. Alright, so here is the app running on the iOS simulator. And as a first step, we can complete the onboarding process. And as part of this, we can set a monthly budget, such as £2,000 per month, for example, like this. And then we can proceed to the next step and complete the onboarding like this. And as you can see, this takes us to the home page. And here we can see a collection of widgets showing our bank account as well as our budget. And as a first step, we could try to add a transaction like this. So we could call this pizza, for example. And then we have to set the category, which in this case will be dining. And then we can make it cost £15, for example, like this. And while we're here, let's add another one. So this time we're going to call it salary, like this. And rather than an expense, I'm going to set it as an income, like this. And here I can enter 1500, for example, like this. So as you can see, as soon as we do this, the bank balance is updated. And if we scroll down, we can see a list of transactions. Not only that, but we can also see the transactions on this page, like this. And there are many other features as well, such as budgets and so on. And while we don't have time to explore all the various features in the app, we can see that it has a lot of functionality for budgeting and tracking expenses. Alright, so now that we have some understanding of what the app does, let's dive into the code. And a good first step is to understand what packages are in use. So as we can see here, we have Drift for the database along with SQLite. And then we can spot Google sign-in. And if we go down a little bit, we can also find the Firebase packages. And this is suggesting that the app uses offline storage, but also Firebase for syncing. If we scroll down a little bit, we can also find provider. And this is likely for dependency management. But what is interesting is that I don't see any dedicated third-party state management packages like Block or Riverpod. And this means that we are probably looking at built-in Flutter state management. And this is not necessarily a bad thing as long as it's done properly. But as we're about to find out, things are pretty messy in the codebase. Anyway, if we scroll down, we can find build runner in the dev dependencies. And this is expected because we are using Drift. And if we carry on, we can find a lot of assets. And overall, I can see that this project has a lot of moving parts. Next up, it's time to look at the codebase itself. And as a warning, we should brace ourselves for a wild ride. So, how big exactly is the codebase? Well, the easiest way to find out is to use this handy tool called cdoc, which you can download from GitHub. So let me go back to the root of the project, and then I can run this command from the terminal. And look at this, wow, we're talking about 103,000 lines of Dart code. And this is excluding any empty lines and generated files. And if we scroll up, things get even more scary, because we can see that the biggest files are the database table files and schema versions. And we also have some massive pages files, like this add transactions page.dart, which is nearly 5,000 lines of code. So remember that name, because we are coming back to it. But what about the test folder? Well, this is where we encounter the first major red flag, because as you can see, this is just the standard widget test that comes when you create a new Flutter project. In other words, there are no tests, zero, nada. And for a production app of this size, how do you make changes without breaking things? This is a pretty big risk. So like I was saying, I suspect we're in for a very wild ride. Alright, so it's time to start our code journey, and a good place to start is the main.dart file. So let's scroll down past this rather long list of imports, and here we find some interesting global flags, like allowed dangerous debug flags. I wonder what these are for. And then comes the main method, which has a whole bunch of initialization logic overwrapped inside a capture logs function. And inside it, this function uses round zone guarded, and it looks like it's just used to log errors, but primarily for development. In fact, I can see that there is a log service class, which is used to log errors to the console, and it also seems to keep a local array of all the logs. And my guess is that these can be exported because there is an export logs function. However, I don't see any calls to Crashlytics or Sentry, and for an app with thousands of users, not tracking production errors automatically is a missed opportunity. And you really need to know when things break for real users without them having to tell you. Anyway, let's get back to the main file and take a closer look at the initialization logic. And what I find a bit unsettling is that we have dependencies such as shared preferences, database, and notification payload that are set as global variables that are declared inside this database global.dart file, like this. And rather than doing this, my choice would have been to use a service locator or a proper dependency injection system. But hang on, it gets worse, because here we also have these functions called load currency JSON, load language name JSON, and initialize settings. And even though they don't explicitly return a value, under the hood they set some other global variables, which isn't really a good idea. Take this load currency JSON function, for example, which doesn't return anything, but it sets this currency's JSON global. And as it stands, we can only guess that this variable should be set once during initialization and only used as a read-only value afterwards. However, nothing stops us from changing its value, and it simply isn't clear whether this should be allowed or not. So I think it would be best to have a more strict and safe way of initializing this without relying on global mutable variables. In any case, let's move on and focus on the top level widget, which is called initialize up. And as we can see, the main thing that this widget does is to return this up widget, which is defined over here. But it also has this unusual refresh up state method, which has an empty call to set state. And to me, this looks like some kind of hack that can be used to force a rebuild of the entire app using the up state key that is defined over here. And this is also something that feels a bit forced and can probably be done in a better way. But for now, let's go ahead and focus on the up widget. And as we can see, this is the actual widget that returns the material up, which in turn is configured with localization, as well as theming and so on. And here we find the home argument, which is a pretty complex widget that creates a stack of widgets. And some of these widgets take keys, such as sidebar state key, snackbar key, loading indeterminate key, loading progress key. And these all appear to be global navigation keys. And indeed, these keys are defined inside a file called navigationframework.dart. And it is full of global keys. But where are they used? Well, for example, we could take this home page state key and do a global project search for it. And as we can see, this is used in 22 different places in the codebase. For example, here inside this wallet details page.dart, we can find a call to home page state key .current state .refresh state. But what does refresh state do? Well, this is yet another empty set state call, forcing a rebuild of the entire home page from potentially anywhere in the app. And this is a problem because it creates complex interdependencies between widgets, where one widget can force a rebuild of another widget using a navigation key. And this is a pretty brute force way of updating the UI. And if I'm honest, I'd be pretty scared of touching this part of the codebase. But anyway, let's get back once again to the main file, where we can find the material app.builder argument. And as you can see, this is yet another complex widget that contains a lot of nested widgets that are used for initializing biometrics, the notification service, app links, and so on. And this is quite inconsistent because earlier on we have seen that some variables were initialized as global variables inside the main method. But here we are using a completely different approach, which seems to rely on inherited widgets that are placed at the top of the widget tree. So once again, it seems that the author hasn't really been consistent with his approach to dependency injection, and it is quite hard to make sense of it all. But you know what? We're just beginning to have fun. And next, I think that we should tackle the homepage.dart, which is defined over here. So let's keep it visible over here so we can better see what we are talking about as we explore the code. And now let's scroll down and we can see that the homepage is a stateful widget. And here we can find some code that is used for animations, scroll controllers, and so on. And then we spot this method called are_all_disabled_after_transactions_list. Well, this looks like some business logic that lives right inside the widget class. Not ideal. And then we find this build method, which seems to use some data from app settings to decide what to show. And app state settings seems to be a global variable that is declared inside the settings.dart file. Well, I'm sorry, but this is another red flag, because we have some mutable global state that can be changed from anywhere, potentially leading to subtle bugs that are hard to track. But let's get back to the homepage build method. Now, this is a widget class, so the build method should just return a widget, right? Well, let's just look at it. Here we declare a gesture detector with a child that depends on a value that is defined inside the global app state settings variable. And here we have another widget that depends on this global is home screen section enabled function, which in turn is defined inside a different file. And then it gets even more fun, because we have this home page sections variable which maps some strings to some widgets using some conditional logic that depends on the build context and some other keys. And this map is quite big, look at it. And then look at this beauty. Here we have a for loop that iterates over app state settings using this function that depends on the build context as a key. And finally, we find this return statement, which returns a massive widget tree, which in turn depends on all the things that we have defined above it. And I mean, just look how long this is. It's a pretty big widget tree, right? So while the homepage UI looks nice and polished, the code is giving me some not so good vibes. Because the thing is, this build method goes on for nearly 200 lines, and this can be problematic for performance, because any state change, even one that should only affect a tiny part of the UI, will likely rebuild this entire widget subtree. And let's not forget that at the top of the widget, we have this refresh state method that is called from a lot of different places. So my advice here would be to break this page into smaller, more manageable widgets, ideally using local state and more targeted UI rebuilds. But you know what? I think it's time to tackle an even bigger beast, which is the mighty app transactions page.dart file. And as a reminder, this page can be triggered by pressing the plus button on the home page, and here we can enter a title, like this, for example, and then select a category, and set a price, like this. So this is what the UI looks like. But what about the code? Well, the first thing that I want to say is that this file is over 5,000 lines of code, which is absolutely massive. But what can we find inside it? Well, if we start from the top and scroll down, we can see that it is a stateful widget, which takes all these different arguments. And then we find so many state variables that they barely fit on my screen. But how many times are these variables updated? Well, if we search for set state, we can see that it's called 44 times on this file alone. So what we have here is a massive widget class that is potentially rebuilt many times, and this can be a performance problem. And indeed, if we scroll down, we find all these helper methods that are used to update the state. And there are just so many of them. And I don't know about you, but I find that there is so much complexity inside this widget that it would be pretty hard to reason about and maintain this code. But wait, we are not done yet, because if we scroll down, we find this addTransactionLocked method. And this is a big, scary asynchronous method. So let's see what it does. For a start, it opens this bottom sheet, which is the one that we can see over here. And then once it is dismissed, it checks these variables to see if they are being set. And then it goes ahead and creates a transaction object. And then it has some conditional logic for adding the default missing values. And below it, there's another condition that checks for closely related transfer correction transaction and uses it to open a different pop-up. And if we keep scrolling, we find this call to create or update the transaction. And this is followed by some animations code. And after that, it sets the upcoming notifications and updates the app settings. And finally, there is a catch block that is used to show a snack bar if something went wrong. So yeah, this method is crazy because it mixes up the UI, business logic, database, global state updates, animations. They are all intertwined. But hold on, what about the build method? Well, it appears that this starts over at line 1050, over here. And can you make a guess at how long this is? Well, to find out, we have to scroll down all the way to line 2218, where we find the end of this widget. And you know what? I'm not even going to try reviewing this, and I'm really starting to feel sorry for any developer that has to maintain this codebase. So yeah, as far as the UI goes, I think we should stop here. And in any case, there are other things that are worth looking at. For example, the database. Now, this is located inside a file called tables.dart, which is over here. And this is a gigantic file with over 7,000 lines of code. So let's see if we can spot some interesting patterns. And at the beginning, we have some constants, followed by some enumerations that are presumably used in some of the database tables. And then after that, we have a bunch of converter classes, like this. And if we keep scrolling down, we find the declarations for all the drift tables. And there are quite a few of them. And some of them, such as the transactions table, are pretty big, as you can see. Okay, so let's keep scrolling. And if we carry on, we end up finding some other classes, which seem to combine different objects together. So there are quite a few of them. And as you can see, some of them include some business logic. And if we keep going down, we eventually find the main drift database class. And this starts with this migration strategy getter variable, which is used for database migrations across different app versions. And if we take a closer look, we can see that over time, different conventions have been used for the migration code. For example, earlier migrations were just a bunch of await calls, but later the author started adding some try-catch blocks with print statements, which were presumably used for debugging, but without any proper error handling code. So let's carry on. And as we can see, there are also some migrations that are more complex and are performed over multiple migration steps. And all this migration code goes on and on and on until line 1262 over here. So this is what the migrations code looks like. But what about the database queries? Well, let's see if we can find a good one. Here it is. And yeah, over here we have this watch total net before start date transaction category with day method, which is pretty complex as far as SQL queries go. And if anything, this shows that the database schema and the queries are just as complex and scary as the UI code. And as far as I can see, if we keep scrolling down, we find many other query methods. And interestingly, some of them are commented out. So again, the author here is not following a particularly good code etiquette. And to be honest, I don't really know if most of this code was written by hand or perhaps with some help from some kind of LLM. Either way, it's pretty wild. And as it turns out, some of this code even depends on the app state settings variable that we discovered earlier on. And honestly, with over 7,000 lines of code, there is so much to unpack here that I'm not even gonna try. Alright, so far we have taken a look at the UI code as well as some of the database code, and we've already discovered some interesting patterns. And perhaps this is a good time to take a step back and look at the overall folder structure. So as you can see, over here we have all these different folders, and this one called struct seems to have quite an odd name. So what's inside it? Well, there seem to be some files for date formatting, perhaps animations, file-based authentication, biometrics, notifications. So it's a bit of a dumping ground, isn't it? But there's even more confusing stuff, because inside this widgets folder, we can find a util folder. And this is another dumping ground that contains things such as uplinks, the bouncing code, animations, mixins, widget lifecycle stuff, file IO. So yeah, quite a lot of different things. So while we have some top level folders, the organization within them seems quite inconsistent. And it's almost as if things were just put wherever was convenient at the time. And without a proper convention that is established and enforced, it gets harder and harder to navigate and understand the codebase. Okay, so we have seen a lot of questionable patterns, but why does this happen? Well, quite often, especially for solo developers like the creator of Cashew, the priority is to ship by adding features, getting users, and growing the business. And that is quite commendable, because based on the reviews and number of downloads, this seems like a successful indie app business. And with this code review, I wasn't trying to be mean or bash the author in any way. However, when a product like this becomes successful, the codebase can grow into a tangled mess if there isn't any dedicated time for refactoring. And there's only so much you can keep pushing before the technical debt catches up to you. And given that this app hasn't had any releases since July 2024, it makes me wonder if the author has given up on its own codebase. And to be fair, now that I've seen what the codebase looks like, I'm quite impressed that it managed to keep it working for so long. And even though there are many problems with this codebase, we can use it as a learning opportunity. So let's make a summary of all the issues that we've encountered and see what could be done better from a software engineering perspective. Starting with issue number 1, which is error monitoring. And from what I've seen, errors are often silenced and only logged to the console, like this. And the very first thing I would do would be to add Crashlytics or Sentry to get a better understanding of what's going on in production. And over time, I'd look at ways of handling errors properly in the app. The second issue is the lack of automated tests. So before doing any major refactoring, I would write some integration tests for the most critical user flows. This way, we can build some kind of safety net so that if we make changes and break something, the tests are likely to fail. On the other hand, I think for this specific project, adding small unit and widget tests is probably a waste of time, especially since large parts of the code are hard to test in the first place, and they need to be refactored anyway. The third issue is the lack of linting tools. And I haven't mentioned this before, but this project doesn't use any linting at all. And at the very least, we could try adding the Flutter lint package to enforce a better code style, and perhaps uncover some deprecated APIs, especially if we want to update the codebase to the latest Flutter version in the future. And once the code is in better shape, we could even look at more advanced linting tools like Dart code metrics. Alright, so the next issue is poor separation of concerns. And as we'll see, there is no clear convention for what goes where. And we have seen many examples where the business logic, UI, and global state are all mixed up. And to tackle this, I would introduce a layered app architecture, such as the one that I propose on my website. This allows us to start reasoning in terms of presentation, domain, and data layer. And alongside this, I would start cleaning up the folder structure, incrementally reorganizing the various parts of the codebase into appropriate layers. And at the very beginning, all these layers would still be tightly coupled with each other, but as we keep refactoring, we should see that the dependencies between them are slowly reduced. Okay, so let's move to the next issue, which is the lack of a dependency injection system or service locator. In fact, another issue that we noticed earlier on is that many dependencies are declared as global variables. And this is not a good idea. And I think it would be best to incrementally move all the global dependencies to a proper dependency injection system, using packages like Riverpod, or perhaps a service locator like Getit. Alright, so the next big issue is mutable global state. And an example of this is in the settings.dart file. And this is potentially one of the biggest problems in the codebase, which can lead to bugs and performance issues. So what I would do is to gradually refactor away from global mutable state by introducing proper state management solutions like Riverpod or Block, which allow you to create separate classes for data mutations, ensuring the UI code is only concerned with fetching data and rendering it. This way, the widgets become more reactive, meaning they can rebuild themselves when the state changes. And this would also help with the next issue, which is widget rebuild via global navigator keys. In fact, as we have seen, there are many instances where certain widgets force other widgets to rebuild by directly accessing their navigator keys and using them to reset their state. Now, this approach creates complex interdependencies between widgets, which is not desirable. Instead, by moving to reactive state management solutions, we can avoid the need for all these global navigator keys. And speaking of widgets, the other issue is massive widget classes. And as we have seen, the home page and the add transaction page are both massive, which makes them very difficult to maintain, but also difficult to test. So to tackle this, I will start by breaking down these large widget classes into smaller, more manageable widgets that have fewer dependencies, using a bottom-up approach. And this would help reduce the complexity of the code base and make it easier to test. Now, I'll admit that making all these changes on a code base of this size is a monumental task. And perhaps the solution here is to make these changes incrementally and use the Boy Scout rule, ensuring that the code is always left in a better state than it was found. Alright, so I think it's time for a wrap up, and I'd like to end on a positive note. So once again, my intent here wasn't to bash the developer who has created an app that has helped thousands of users all by himself. And the fact that the Cashew app is open source is fantastic because it provided us with many valuable learning opportunities. And I hope this code review has given you a real sense for how technical debt can accumulate, what impact it can have, what you should do in your apps to prevent it, and the importance of core software principles, even for solo projects. But how can you avoid making the same mistakes in your own apps? Well, if you head over to my website, you can find a lot of tutorials and articles that will help you with your Flutter app development. And if you want to take things further, you can take my Flutter Introduction course, which will help you ship your apps with confidence, with over 200 lessons covering topics such as flavors, error monitoring, analytics, submitting your app to the stores, release automation, and much more. And if you use the link in the description below, you can get $20 off the full price. Finally, I hope you enjoyed this video. If you found it helpful and would like more videos like this, please like and subscribe. And let me know in the comments below if you have any feedback about how I can improve. Alright, so thanks for watching, and I'll see you on the next one.